Assalamu alaikum dear students. In previous lecture we discussed the invertible functions, that is those functions whose inverse exists are called as invertible functions. Inverse of a function is again a function from codomain of the given function to its domain. Now how to find the inverse of a given function? You should remember that the necessary and sufficient condition for f or for a given function to be invertible, that how to check whether the given function or whether the inverse exists for the given function or not. You should simply check that it is bijective. If the function is bijective, then its inverse exists. Like if we consider here a function from f from r1 to interval 4 to infinity, defined by f of x equals to x square plus 4. Is f invertible function? That's we have to check whether the inverse exists or not. If so, we have to find its inverse, where this r positive is set of non-negative real numbers. Non-negative real numbers means those only positive numbers including 0, while as non-positive means 0 with negative numbers. Now firstly we will prove that this function from r1 or r plus to 4 infinity, defined by f of x equals to x square plus 4, is 1 function and onto function. Now for 1 how to check? Now we take 2 points x1 x2 arbitrarily points from this r positive, such that f of x1 equals to f of x2, which implies that x1 square plus 4 equals to x2 square plus 4, which implies that x1 square equals to x2 square. Now if we put roots on both sides, which implies that x equals to plus minus x2, x1 equals to plus minus x2, that is either x1 is x2 or x1 is minus x2. But here this or this given domain is positive, so there are not the negative numbers, so this means that we have to cancel the negative sign. Hence only one situation exists here. It is simply x1 equals to x2. So this means that both functions, this function is 1 function, because f of x1 equals to x2 implies that x1 equals to x2, that is the given function is 1 function. Now for onto, now we prove this by the contradiction method. Now if f is onto, so this means that for any arbitrarily point of codomain is actually the range element or the range point. Now let's assume that this y belongs to this 4 infinity, that is y is arbitrarily element. So when it is onto, this means that there exists x belongs to this r positive, such that f of x equals to y, f of x equals to y. Now x square plus 4 equals to y, because f of x is defined by x square plus 4. So it is x square plus 4 equals to y, or x square equals to y minus 4. Here we have to find the value, or we have to check the behavior of x, because we know y but we don't know this x is the arbitrarily, which implies that x equals to plus minus root this x equals to plus minus root y minus 4. But x belongs to r positive, that is x is greater or equals to 0, so we have to cancel this negative sign, that is x equals to root of 4 y minus 4. You know that real root of positive real is defined, while as root of negative is not defined. Now we will check whether this y minus 4 is positive or not. Now y belongs to 4 to infinity, this which implies that y is always greater or equals to 4. Now when y is always greater or equals to 4 implies that y minus 4 is greater or equals to 0. So when y minus 4 is greater or equals to 0 implies that root of minus y minus 4 is defined, that is it is a real number, and root of positive number is positive. So this means that this x defined by root of y minus 4 is defined. Hence the given assumption is true, so we conclude that this function is onto function. such that f of x, now x here is of the form of root y minus 4, because x equals to root minus 4 is, for this x, root y minus 4 equals to y. So clearly this function is onto function. Now when it is onto, when it is 1 it is bijective, and you know that the necessary and sufficient condition for function to be invertible as the function should be bijective. So this means that this f is invertible. Now how to find, the such and this inverse or such function? Since we proved from this onto function that for each y there exists x belongs to R positive, x is of the form of root of y minus 4, such that f of x equals to y, or root of y minus 4 is y. This we proved in onto function. Now let g be the inverse of f, that is g is the function from codomain, which is 4 to infinity, interval 4 to infinity or positive. Now if we define this function by g of y equals to root y minus 4. Now if we define this function by root y minus 4. Now here y is this variable in this 4 infinity. Now if we put this y in place, if we replace this y by x, because x is variable, y is variable, so it doesn't alter this function. So clearly for simplicity we put g of y equals to root y minus 4 as g of x equals to root x minus 4. Now we have defined this function. Now we assume that this is onto this inverse of g. For inverse, if if g is the inverse of f, then f of g is identity and g of f is identity function. Now here we will define f of g. Now f of g of x equals to f of g of x, because this is the definition of the composition of two functions. Now g of x is defined by root x minus y, but f of x is defined by x square plus 4. Here x is root x minus 4, that is root x minus 4 whole square plus 4. Now root and square cancels, it is x minus 4 plus 4, which is x. So each x is mapped with x. Similarly, we can also check that g of f equals to g of f of x. It is g of x square plus 4, because f of x is defined as x square plus 4. Now here g of x is defined by root of y minus 4, which is x square plus 4 minus 4 plus 4 cancels, it is simply root x square, which is x. So both f of g as well as g of f are the identity functions on their respective domains, or from their respective domains. So we conclude from their definition of the inverse that g is the inverse of f, that is f inverse equals to g, it is simply root of x square minus 4. Here, like here, if we consider this visually as R positive, that is domain of f, 4 to infinity is the codomain of f, while as this g, it is the 4 infinity is the domain of for this g, while as this R positive is codomain. Now this x is related with this y, which is of the form of x square plus 4. Now this x square plus 4, that is y, it is again mapped with this x, which is of the form of root x minus 4, root x minus 4. So this means the inverse, and you can find for inverse of any function if it exists. So in order to exist, for existence, you simply need to prove whether the given function is bijective or not. So thank you.